Now let's look at specifying the load and base case power system for this off-grid telecommunications site in Ecuador. The AC electricity requirement, as mentioned earlier, is 25 kilowatt hours per day. The peak load is 5 kilowatts. The system must provide power for 24 hours a day, 7 days a week. In the base case, we'll use a diesel-powered generator. And the fuel price we can assume is 60 US cents per liter delivered to this remote site. The pump price of diesel in Ecuador is actually quite a bit lower than that. The annual operation and maintenance cost for the genset are going to be 1,000 US dollars per year. Now, pause this video, complete the electricity and fuels and power system and load characteristics pages, and then unpause to see the solution. Before we proceed further, I'm going to show you how you can save your work. I'm going to go to the File page, and I'm going to click Save As, and I'm going to specify a name here. Telecommunications site suits me fine, and I'm going to save it. Now we proceed to the Energy page here, and I'll start by going to Electricity and Fuels. I'll ignore this part, the electricity rate here. That's not going to play a role in this. However, I do need to specify that we're going to be using, at least in the base case, diesel fuel. So I'm going to pick diesel number 2 oil with the units of liters here, and I'm going to indicate that the price is 60 US cents per liter. Next, I can go to the Power System and Load Characteristics page. I'll leave this on Method 1. It's adequate for specifying the load using the information we have. It is a reciprocating engine that's being used in the base case, and it is running on diesel. There's the price being carried over. The capacity, I'm going to assume that it's a 7 kilowatt system. A 5 kilowatt system would most likely be sufficient, but it's hard to find 5 kilowatt diesel generators. For the heat rate, I'm going to use help here. So this is in a way specifying the efficiency of our generator. I am going to use the lower heating value here. The LHV indicates that these are typical heat rates for reciprocating engines using the lower heating value fuel convention. And I see that the heat rate is about 12,000 for very small generators. So that's 12,000 kilojoules of fuel energy expressed using the convention of the lower heating value required to generate 1 kilowatt hour of electricity. For the annual O&M costs, we indicated that they're about 1,000 US dollars per year. Remember, this diesel-fired generator is operating 24 hours a day around the year, so there's going to be some maintenance required. For the daily electricity requirement, it's all AC, 25 kilowatt hours, in both the base case and the proposed case. And I'm going to assume that it's operating all the time, day and night, so there's zero correlation between the availability of solar energy in the proposed case and our load. Finally, down here at the bottom, I'm going to specify that the peak load is 5 kilowatts. We see the total annual load is 9,125 kilowatt hours in both the base case and the proposed case. Because there's no difference between the two, we don't have to enter anything for incremental initial costs. In the next video, we will specify the proposed case, that is the solar system, inverter, and battery.